Well, good afternoon and welcome. I'm very delighted in a very special way to welcome you to this afternoon's lecture. And it's really with great gratitude that we welcome Dr. Jim Wyant here today as our esteemed lecturer. He's been here many times before, but not in this capacity. Dr. Wyant and his spouse, the late Louise Doherty Wyant, class of '63, generously endowed the Wyant Professorship and Lecture Series in honor of one of Louise's former Emmanuel professors, Sister Anne Cyril Delaney, Sister of Notre Dame. What happened? Emmanuel has had two wonderful Wyant professors in the course of the last several years. Professor of History with a focus on Russian history, remember Dr. Pat Herlihy was our first Wyant endowed chair, and Professor of Political Science, who's here today, Dr. Lenore Martin, both of whom have helped to bring distinguished professors, journalists, cultural ambassadors, and actors to address our community in the humanities, history, and the arts, which was the purpose of the Wyant Endowed Professorship. From the beginning, we have had the pleasure of welcoming, just for our lecture series, such lecturers as Sergei Khrushchev, son of Nikita, Gordon Wood, Pulitzer Prize-winning author, Kate Burton, actress, daughter of Richard Burton, and Nirupama Rao, Indian ambassador to the United States. And today, you are sure to be inspired by the words of a professor, inventor, and entrepreneur, Dr. Jim Wyant, and by the energy and enthusiasm he has for his amazing work. He's the founding dean of the College of Optical Sciences at the University of Arizona in Tucson, where he's a professor emeritus, both of optical sciences and of electrical and computer engineering. In addition to his work at the university, he has engaged in several entrepreneurial ventures, including the founding of two high-tech companies. As a result, he's received numerous awards, including Arizona's Innovator of the Year Product Award and the University of Arizona's Technology Innovation Award. Dr. Wyant truly possesses the qualities of a great teacher, and it is my privilege to welcome him here today to Emmanuel College. Welcome, Jim.
Okay, well, thank you very much. I'm very honored to be invited here, especially after hearing all the previous speakers you've had here. So, is there anyone here who would like to start a company someday? Ah, good. There are a few. Is there anyone here who's already started a company? Good. Excellent. Well, I think that starting and growing a company and then cashing out is certainly one of the most exciting things you could ever do. It just is a fantastic amount of fun. Now, it's not for everyone, I'd have to say. You know, if you are a person who likes to work, say, from 9 to 5, 5 days a week, probably starting a company is not the right thing to do. But, you know, if you're the type of person who likes to work, let's say, 12 hours a day, for 7 days a week, it's a perfect job. Well, it's not quite that bad, but it does take a lot of work. But it truly is a lot of fun. And I hope what I'm going to do this afternoon is to show you some of the fun that I had. And I'm going to talk, for the most part, I'll talk about Waco, how we started it, and a little bit on the growing and then on cashing out and what we learned. And then I'll talk a little bit about a company, 4D Technology, which is a company that I'm still involved with. So if I go back to Waco, it actually goes back a long time ago. It went back to 1982. And if you look on the left here, you'll see the door to my lab at the university. So this company grew out of the research that I was doing at the company. And when I say I mean, you know, when a professor says I, he probably really means his students. So it grew out of the work that my students were doing at the university. And So it really goes back a little bit before I went to the university, actually. When I got my PhD in 1968, and I moved here to the Boston area, and I went to work for a company called iTech, which was out in Lexington and in Burlington. And I ended up working there for 6 years. And it was a fantastic job. I mean, we had freedom to do whatever we wanted to do. We had plenty of money for equipment. Unfortunately, in those days, I didn't know how to spend money, and I didn't take advantage of this. Now I know how to spend money, but I don't have it anymore. So anyway, maybe that's why I don't have it anymore. I know how to spend it. Very smart people to work with, and as I look up here and see a lot of students, I tell you, your first job you want to make sure you go work with some very, very smart people. Because when you get your degree, you think, well, I really know a lot. Well, the older you get, the more you realize you really didn't know very much. And if you can work with some smart people, you'll learn a lot more. So that was good. The other thing we had at iTech was that we had marketing people who brought us interesting problems. So the real business of iTech, has anyone here heard of iTech? It's gone now, but yeah, okay. The real business was spy satellites, but I wasn't really working in that area. I was doing more research and development. And these marketing people would come to us with problems that people wanted solved. And if we wanted to work on these problems, we could. If we didn't want to, we didn't have to. I mean, it was a perfect job. Sometimes today, students will ask me, where can I get a job like you had at Waco? And I don't have an answer for that. I don't know where you can get a great job like that now. It used to be Bell Labs was a place like that, and iTech was a place. But for me, it was wonderful. And we came up with a lot of really neat ideas. And I have to admit, though, that most of these ideas, while they were neat, they were almost useless. At that time, anyway, they were almost useless. Because most of them depended upon having some technology we didn't have back then. Maybe we needed computers. And if you go back to the period of time I'm talking about here, late 60s, early 70s, we didn't have such a thing as a personal computer. We needed electronics that we didn't have back then. You needed good cameras. We all have a smartphone of some type now. It has a camera in it with many megapixels. I would have killed someone back in the late 60s to have something like this. So we had all these great ideas, and we had a lot of fun playing with them. But to be truthful, I'd have to say that the ideas I had back then really didn't make iTech that much money, because we didn't have the rest of the technology we needed to take advantage of those ideas. Well, anyway, I worked at iTech for 6 years, and the person who hired me at iTech left shortly after hiring me, and he took a faculty position out at the University of Arizona, where they were setting up an optical sciences program. And in 1974, when I was out at Arizona interviewing students to come to work at iTech, they asked me if I wanted a faculty position, and it took me less than a microsecond to say, yes, I did. And somehow the excitement of being a faculty member and the excitement of going out west, I just couldn't turn down. So Louise and I moved to Tucson, Arizona in August of 74, which is not a great time to move to Tucson, I might say. It's a little bit on the warm side. And I can remember the first week there, I walked to the student union to get lunch, and I walked back to my office, and I'd just be exhausted from all the heat. And I'd say, what have I done to myself, But anyway, we were out there. Anyway, I had a lot of fun and worked hard, and I went out there as an untenured assistant professor. And in a couple of years, I got tenure and made associate professor. Another 3 years, I was made a full professor. So I had a nice group of students doing a lot of research, and I had very good funding and teaching some interesting courses. But by the early 80s, I got kind of tired with what I was doing. A little bored with what I was doing. And I decided I really wanted to start a company. But if you're going to start a company, what kind of company is going to be? Well, if I'm going to start a company, it has to be a technical company because that's the only thing I know. So I had to have a product. And I didn't have any ideas for a product. And then in 1981, I was doing some work for Los Alamos National Lab. And as part of that work, they sent me to Oak Ridge, Tennessee to look at where they were doing some diamond turning of optics. Now, diamond turning of optics is essentially using a milling machine to mill out the surface, metal, aluminum, whatever, copper, mirror. And at Los Alamos, they were doing work on laser fusion, and they wanted these mirrors for their project. So I went out to Oak Ridge, Tennessee, and I saw these what they were doing with these diamond-turned optics. And the optics weren't very good. They had to inspect all of them. And their way of doing the inspection was they had a whole row of microscopes set up, and they were looking at these mirrors under the microscope, and they were taking Polaroid pictures of what they saw. And then they had a ruler and pencil and stuff, and they were measuring stuff off of these pictures. So they had a whole group of people doing that. And I said, there must be a better way of doing that. So I went back to Los Alamos and said, I want to develop a better way of inspecting these mirrors, and will you fund me? And so they gave me some money, this was at the university, some research funds at the university. Wanted to develop a better way of inspecting these mirrors. So the first thing I did was I found the best graduate student I could find to work on the project. That's what you professors always do. Find the best student you can. And we began working on the project. And we were kind of fumbling around for a while and couldn't really figure out just what it was we were going to do. But some way we're going to make this automated interference microscope for measuring these diamond turns. Then I got to thinking back to some of the work that I did at ITech. Some of the work that wasn't very useful at that time. And I got to thinking, this is now the early 80s, and we're beginning to get computers. We're beginning to get detector arrays. And we're beginning to get the electronics. So I'm thinking maybe we can use some of this technology that we developed at ITech to make these. And so this is not intended to be a technical talk at all, but I have to show a couple of diagrams like this. But all you need to really know is that this is let me see. This is a microscope here, and down here is a sample that we're looking at. So that could be our diamond turn mirror. And then we have a microscope objective looking at that. And we're doing interferometry. And I know that there's a few in the audience who know what I mean by interferometry, and there's probably more who don't. But I just say that light comes down here, reflects off, some of the light reflects off here up to the reference surface, back down here, back out, and some of the light goes down to the sample and back here. And what we're really doing we are comparing the shape of this with the shape of this reference surface. And if I look up here where my detector is, I'm going to see what's called an interference pattern. You see these lines. The only thing you need to know here is that if this surface were perfect, these lines would be straight and equally spaced. And what the people in Oak Ridge, Tennessee were doing with a ruler, they were measuring how much these lines departed from being straight. From that you can determine what the surface is. Well, we didn't want to do that. We wanted to do everything in the computer. So we put a computer up here. We put a detector here and interfaced that to a computer sitting over here someplace. And we wanted to then measure these surfaces automatically. And we built some prototypes, and I don't have a picture of the first prototype that that we built. In fact, I should give you, those of you who want to start a company, I'm going to tell you what you should do. Take pictures of everything. So later when you're giving talks about the company, you have pictures to show. Because I have to kind of fake it here. This wasn't quite the first microscope we did, but maybe second or third. And it just happened to be one that I still have sitting out in my garage, and so I could take a picture of it. So this is almost like what the first one was. This was a lot of fun. There was only one thing wrong with it, and that is that all the data coming, so this was connected to the computer, and all the data displayed on the computer was complete garbage. The output of this microscope was just random noise. It was horrible. But it didn't stop me from showing it to people and kind of dreaming what it could be like someday. And I remember taking this to an Optical Society of America meeting in Florida, and I showed this to a few hundred people. And there was only one guy, I remember his name, Huffnagel was his last name, only one guy who realized that I had garbage coming out of this instrument. Everyone else thought I had real good data coming out. And the reason that worked is that this thing was so slow that no one, they would see one measurement, no one wanted to wait around and see a second measurement. If they had stayed to see the second measurement, they would see that's completely different from the first measurement, because it was just generating random noise. And the problem, we were pretty good at optics. We were, pretty good at software and mechanical things, but we were terrible at electronics. And all the electronics that went between our detector here and the computer, we didn't know what we were doing. And it was just, so we were getting just garbage out of the system. Then we got two gifts from heaven, I have to mention. I tell you, luck is a lot of, determines whether you succeed or not, is your luck. One day I got a letter from an Englishman by the name of Keith Prettyjohns, who wanted to become a postdoc. He wanted to come to the U.S., and he knew electronics. And he even claimed that for his dissertation he had interfaced a detector, very similar to ours, to a computer. It was just exactly what we wanted. So I offered him a position as a postdoc working for me. When he showed up, not only did he know electronics, but he had a great personality. He was a great salesman. He was a great marketing person. He was also very tall. He could have been a great basketball player, but that wasn't the part I was interested in. But he was just perfect. So anyway, he began working on the electronics. The second gift from heaven, this is even a bigger one here. So IBM had a big facility in Tucson. And there was a man working there by the name of Brat Bouchon, who is an MIT graduate, working for IBM. Nowadays he's a professor at Ohio State. But anyway, Brat's boss said, this university over there, they must be doing something useful that we could take advantage of. Can go over and find out if there's anything they're doing that's useful for us. So some way Brat got my name, and so he came over to see me. And we talked about possible things we could do for him. And he said, well, he had magnetic tape, and he wanted to measure the roughness of the tape. He wanted to know if we could do that. And of course, my answer, whenever anyone asks me, can you do something, I always say, oh, yes. And then later I kind of think, well, how do we actually do that, But, some way you always figure it out. So he wanted to measure this magnetic tape. And I got thinking, this is almost perfect for this microscope, maybe. Now, the thing that, of course, our microscope was producing garbage. The noise, the signal coming out of it was pretty much random noise. But the thing that saved us, if you ever looked at a piece of magnetic tape, the surface is pretty random. It's kind of like random noise itself. And so when we measure that on the microscope, it actually gave results that Brat thought might even be good. And so we began measuring tapes for him. And, he was a hard worker. He was really a hard worker. And he pushed us pretty hard. And I remember one night, it was a Sunday night, it was 10 o'clock at night, and he called me. He said, I have about 20 samples of magnetic tape I want you to measure. And I said, okay. And he says, I need to give a presentation on it at 9 o'clock tomorrow morning. Well, I said, okay. I said, bring the tape over. And I had the microscope at home, because I'd taken it home for the weekend trying to get the stupid thing to work better. And so there was no problem. So he brought the tapes over, and I measured them, and he gave his presentation, and all the random noise and stuff. Somehow it made a little correlation, and he was really excited about it. He said, I want to buy one of those microscopes. I said, okay. I said, well, we have started a company, Waco. We hadn't actually started a company called Waco, but I said to him, we've started a company called Waco, and we'd rather make this microscope at Waco than at the university. He said, okay, that's okay. So how much will it cost? I had no idea what it should cost, so I said, oh, $100,000, So he said, okay. And then I said, and we need 60% up front to buy the parts for it. I said, okay. And he went away, and I didn't know if I'd ever hear from him again or not. But in a few weeks, I got a check in the mail from IBM for $60,000. So I was really excited here. So first thing I do, I go off to the bank to cash it. There was a big problem here. The check was made out to Waco, and there was no Waco. So I couldn't cash a check. So we changed that. We started Waco Optical Inc. on December 27th, 1982. And there were four of us to start. There was Chris Koleopoulos, who had been my student. And he had just finished up his PhD. And he had taken a job as an assistant professor at Optical Sciences. And so the name Waco came from my name, Wyant, and his name. And then there was Steve Lang, who was a research assistant working for me. And then there was Keith Prettyjohns, my postdoc, and myself. So we started this December 27th, 1982. And I have to say that was a mistake, too. December 27th. What happens 5 days later? Income tax is what happens 5 days later. We would have been much wiser waiting until January 2nd, but I wanted to cash that check. So we did it. So we rented a small area here in a building, and this is, again, I didn't take this picture back at that time. I took it just 4 or 5 years ago. But we had a spot here. I mean, we had a small room, and when I say small, it was maybe 1/6 the size of this area up here. I mean, it was really small. But it was sort of big enough, because there were four of us who started it. But the great plan we had was that Keith, Chris, and I would stay at the university. And only Steve would leave and do the company. And Steve would do all the work, and we'd all get rich. That was the idea. And so we didn't need a very big place just for Steve. So that's what we had. And we had goals, Waco had goals. We had basically two goals. One was, and the second, what would the second be? Make money. Okay, those are the two goals. Have fun and make money. Well, the truth of the matter is, we were not having fun, and we were not making money. The problem was, this microscope system we sold to IBM, we could not get it to work. It just kept generating this random noise. And we just could not get it to work. And so every month, the purchasing agent at IBM would contact me and say, where's our microscope? Every month I would send him a letter saying, I'm sorry, we couldn't deliver it this month, but we'll deliver it next month. Next month would come along, I'd change the date on the letter and send it again. I just kept repeating this up. We could not get it to work. September of '84 came along, and I said, we have to do something. This is no fun. And if we're going to do this, we have to get serious, and 3 of us can't stay at the university, and can't expect poor Steve to do everything. And so I went down to 20% time at the university, and I went to nearly full-time at Waco. I say 80 hours per week, but it certainly was a lot of time. And Keith also came over. Chris and I had some disagreements, so he left. But I had another student, John Hayes, just getting his PhD, so he came over to the company. And so then we rented a little larger space, because now we had 4 people working, we needed a little more space. And we rented this building here. Now, this was maybe 2,500 square feet or so. Now, at this time, we also changed the name of the company from Waco Optical just to Waco Corporation. So why did we do that? Well, this were 2 buildings next to each other. We were in one of the buildings. And in the other building, there was a podiatrist and a dentist. And so we had all kinds of people coming to our place wanting to buy glasses, And maybe we would have made more money if we were selling glasses, I don't know, but that's not what we wanted to do. And so we took optical out of our name and just used Waco Corporation. Now, some of my friends said that a better name would have been Waco, but anyway, at this point, we truly did get very serious, end of '84, and we worked very hard, and we did make this system that worked for IBM. And it worked extremely well. And this particular system, we sold more than 1,000 of this particular model. It had fantastic measurement accuracy. In fact, it could measure down to like your diameter of your hair down to like 1 part in a million to a millionth diameter of your hair. Now, my hair is mostly diameter of 0, so I couldn't do a millionth of that. But it was a fantastic instrument, and we sold a lot of these, and so many that I have this picture hanging in my living room at home. And I'll just show a couple of results from here. This is looking at a linear scan of one of these diamond turn mirrors, and you see little grooves in it. So the heights here, for those of you like nanometers, that's in nanometers, and that's looking over a small portion, about 0.6 of a millimeter sample on it. So very, very high, very good height resolution, and you can look over areas and so on. So, I mean, this was great. This was an instrument that really worked well. It was an instrument that a lot of people wanted and had a need for. And it was an instrument that no one else had one that had these capabilities. So we had the market to ourselves for a couple of years, and then, of course, the competitors realized we were selling a lot of these, and so we got competitors. So we moved to another building, expanded. And this picture was taken by a visitor from Kodak. And I thought this rainbow was really very, very nice. Well, anyway, things are going along, and we're developing other products, quite a number of other products. I'll just show one. I'll show one that made us absolutely no money. And in fact, it cost us money. Well, why am I talking about it? I'm talking about it because it taught me something that ended up being pretty valuable. So this instrument, we got sued for patent infringement on this instrument. And it's a patent that I knew about before, and we'd gotten an attorney's opinion on it, and he said if we did this, that, and the other thing, we wouldn't be infringing, but someone else disagreed with that, so we got sued. So what did I learn from this? Well, up to this point in my life, I always thought to get a patent, you had to have a Nobel Prize winning idea. But I saw that, the patent that got us in trouble on this was a very, very simple thing that I don't think should ever have been a patent. But it really taught me that if you're going to be in a high-tech business, you need to have patents. You need to have a way of keeping people from coming after what you're doing, or if someone sues you, you have patents to trade. And it doesn't have to be a Nobel Prize winning idea to do the patent. And so After this, we began filing for patents, and at the time we sold the company, we had like 45 patents, and that certainly helped the value of the company, because some of these patents were actually pretty good patents. We kept growing. We now purchased a building that had been an IBM building at one time, moved into that. And as I said, we develop other products. Well, this instrument we had, this microscope system, was so good at measuring smooth surfaces, but it couldn't measure real rough surfaces. And we had a lot of potential customers who wanted something to measure rougher surfaces. And so we made a small modification here. So this is the same microscope system as before, but we took out a red filter that was in it, and we added a lot of computer processing. Now, for many years, I knew that we could measure rough surfaces. I knew basically how to do it, but it required a tremendous amount of computer processing, and we didn't have computers that could do that. And about this time, there was DSPs, digital signal processors, came out that looked like they could do the processing that we wanted. And so I wanted to see if it would. And I found a person who knew a lot about DSPs, and we hired him. And so we built another system that was very similar to what we'd been selling before, except for this fantastic computer processing that we were able to do. And now we could measure almost anything. I mean, here's a step. We would not have been able to measure that before. Here's a print roller, has little pits in it. A lot of interest in measuring these. We could now measure these and see how deep the pits were and so on. This is a piece of paper. We could measure paper. Micro machine piece of silicon. Artificial heart valve. Inside of a Saturn engine, could measure the honing marks inside the cylinder bore. Magnetic recording heads. Now we had many different markets now that we could sell basically the same product into. And we did sell into all these markets. But the one that really did well, the best, was the magnetic recording heads. Because just at this time, we were getting more and more personal computers, and every personal computer had a hard disk drive in it. And this instrument could measure the roughness of this hard disk drive and the shape of the recording head. And that's what this is. A simple one. The more complex ones I can't. But we could measure all of these recording heads. And so it turned out everyone in the world who was making hard disk drives bought our instruments. And we sold thousands of these instruments all around the world. And for a while, we didn't have any competition. And I tell you, when you have an instrument that would do something that people want and you don't have competition, that is really fun. I'll guarantee it. That's a lot of fun. We also did some work in the bump measurement, or in the semiconductor industry. But the magnetic recording heads was really where the most money was made. It was great. And these instruments still are used in that area. But anyway, we were having fun and we were making money. And I have to show you one more product here. Well, I'm still talking about Waco. And this is a product that didn't make any money, but boy, was it a lot of fun. In fact, it lost money, but it was a lot of fun. So basically, I don't want to go into technical details, but it turns out if you project lines onto something, and then you view these lines and intersect the surface, and then you view this at a different angle, you can measure the shape of the surface. And by controlling the spacing of the lines and the angles here, you can vary the sensitivity of the test. It's a very versatile idea. Not especially new, very versatile. But what we did, we added our electronics and our way of measurement and our software to this. And we ended up with something that was really good for measuring things like, well, these are cans, okay, measuring the shape of a can. measuring and then finding slopes inside. This is a person's hand. In fact, I even know it's John Meiling's hand. And then the one that I really am showing this to you for, foot. This is someone's foot. So I have to tell you the story. When I say this lost us money, here's how we lost money. But boy, did we have fun. So one day we had this guy stop in to see us, just off the street. You know, normally someone's coming to see you, they make an appointment, but this guy just showed up. And he said he wanted us to do something for him, but he wouldn't tell us what he wanted us to do. He was so secretive. He was the most secretive guy I've ever seen in my life. How can we do this, if you won't tell us what it is you want us to do? Well, he wasn't going to tell us. So I decided I have to get rid of this guy. I'll give him a little tour, and I'll end up by the front door, and then I'll give him a little shove and say goodbye. Okay. So we're going on this tour, and we go into the room where we're measuring, we're projecting these lines and measuring things. And he got all excited. And he took off his shoe, took off his sock, and he held his foot up at just the right height. It just fit, And this light foot, he said, measure the bottom of my foot. I pressed the button on the computer, and this was my first measurement. It worked, the very first try. So I didn't try it a second time, but because it worked the very first time. And he became all excited. Then he would tell us what it was he wanted to do. So he was a podiatrist, and I guess, at least then, I don't know if it's still true or not, but when you get orthotics, they put some plaster on your foot, and they get the mold from that, and they send that off to a lab, and I don't know, a few days or weeks later, you get your orthotic. So his idea was that every podiatrist would have one of these instruments in his lab, and you would go in there and they'd measure your foot, they'd send that over the phone lines to internet, this is before the internet really, but phone lines to a lab that have a milling machine. They would mill out your orthotic and they would FedEx it to you and you have it the next day. And this sounded great, we're going to make millions here doing this. And so we formed a joint venture. And we built an instrument for measuring feet. And this instrument worked well. It was superb. It just did everything that he was dreaming about. Except for there was one problem. For us to make money, we had to charge $12,000 for this instrument. And the podiatrists were willing to pay a maximum of $2,500. So, big problem. So we ended up in a little lawsuit, stopped the foot scanner, just couldn't make money there. But you have an opportunity here, because I still have 2 of these foot scanners in my garage. And if you see me after the talk, if you're interested in one, I can give you a very special deal today, okay? True story. Well, we were doing pretty well. We had sales offices all around the world. We even had one in the Boston area here. And we sold a lot over in the Pac Rim, a lot in Europe. And we were doing pretty well. We had a lot of patents and stuff. And we were having fun. But the truth of the matter is I was getting tired. I was getting worn out. And I also was getting to a point where I knew that if I was going to go back to the university to teach, I had to do it soon. And so, we founded the company at the end of '82, and we sold the company in July of '97 to a company called Waco. And the way we sold it, we didn't take any money at all. We just took stock. Waco was a publicly traded company, and so we just that was my way of taking Waco public, and worked out pretty well. I mean, it was sad. It's sort of like you raise your kids, and they get up to a certain age, and they move out, and they're on their own. And that was kind of the same thing when we sold Waco. It was sad, but it gave me the opportunity to go back to university. So let me kind of summarize at this point, what have I learned up to this point before we get on to the next company. A big surprise is the difference between a research project and a product. Research project, you stay up late at night, you get something to work once, you get some data, and you publish it, and that's great. At least that's what I used to do. But for a product, you have to make something that not only you can make work, but you can ship it halfway around the world. Someone can take it out of the box and set it up, and they can make it work day after day after day. That's a big difference and a big challenge. It's different, but it's a big challenge. Difference between cost of parts for the product and the cost to design, sell, produce, and maintain product. Sometimes I'll be talking to someone who's starting a company who'll say, well, I can make this for $20,000. If I sell it for $25,000, I make $5,000. That's great. Well, he's going to go out of business before long because there's so many other expenses involved. And you want to have a high enough profit margin, I always felt. You have to have a high enough product margin that when you sell it, and if they have any problems at all, you're willing to fix it, go out, jump on a plane, or whatever it takes to get it working again. You have to give good service. Another thing, the amount of money it takes to run a company. You think, well, I have to design something, I build prototypes, I build the product, I sell it, I deliver it, and then it's another 30 or 60 days or something before I get paid. So it's a long time between when you begin spending money and when you actually get paid. I mentioned personnel problems. I don't think we ever had any real serious personnel problems, but other companies I've been involved with, it's pretty common. It can be a serious problem. Most important, you have to have a product that people want to buy. Whenever I'm talking to someone about a company, I say, well, the product, does it work? They say yes. I say, does anyone really care that it works? So you have to have something that people want to buy, willing to pay money for. You have to be willing to do whatever it takes to get the job done. You have to be good at hiring people. That's so key because one person is pretty limited what one person can do. You really have to hire a good team. And you want to hire people that fill in the areas that you are weak at. Must have, you really have to have dedication to the company. Timing is everything. I think of the success we had with Waco. We just did it at the right time. Computers just became available. Detectors, electronic stuff just became available. Hard drives, people just wanted more and more hard drives, and so they had to have a way of testing them. Just so lucky on the timing. And speaking of luck, you have to have a lot of luck. I think the difference between a company succeeding and failing could just be a little bit on luck. So anyway, sold Waco. I went back to university. I put together a research team, students, and then after being back there a short period of time, I had the opportunity to become the head of the optics program at Arizona. And then we grew that program a lot, and so instead of being a center, it became a separate college at the University of Arizona, and I became the dean of that. So I was having a lot of fun. But you know what? Doing companies is a disease, and I just missed it. Teaching is fun, working with students is fun, and being a dean is a little bit like running a company, but it's not quite. And so I had to do something, and that came along 4D technology. So I'm going to just say a little bit about 4D and how that came to be. So I have a slide here with a lot of words on. You don't need to worry about the words so much, but a big problem we had at Waco was on vibration. Any little bit of vibration would bother us. We were measuring things, like I said, the hair divided by 1,000,000, real, very sensitive. Airplanes flying overhead, we could detect them, very sensitive vibration. And after selling Waco, I said, some way we're going to solve that vibration problem. And so when I began doing research at the university, it was on solving this vibration problem. And I put together a good team, and we came up with some good ideas, and we published a number of papers and stuff. But none of these really were ideas that you could build a product on. One day, I heard that there was this company in Irvine, California, that had come up with a way of getting rid of these vibration problems. So I flew over to Irvine, California, and what I saw was amazing. It was just fantastic what they had done. They really had gotten rid of the problems with vibration. I could set up part of the instrument here and whatever it is I'm testing over there, and I have no vibration isolation or anything, and you could measure it. It was like a dream come true, what they were doing. I said to myself, I have to have this. I just have to have this. So we went out to lunch, and I made an offer to buy the company. I mean, it was a small company. It was a 4-person company. And it turns out they were having severe financial problems. They were about ready to go bankrupt anyway. So I ended up buying the technology from the company. And I started a company in Tucson called 4D Technology, and we transferred that technology over to 4D. And so now we could measure stuff, where no vibration isolation tables, instruments on one table, what we're measuring on something else. It worked great. If you have, this is an example. I kind of like this. I like this instrument so much I took it to class one day, and someone was drinking a cup of coffee in class. And you're not allowed to drink in the classrooms, but anyway, someone was drinking a cup of coffee in class. And I set this in the beam, and so that's sort of the lower part, be the cup. And you could see the heat waves coming up. So we could measure, not only in the presence of vibration, but we could measure these changes in the refractive index of the air. Or, another example, let's say we have something whose shape is changing with time. We could measure how this shape is changing with time. So we were off and going again. So once again, we're back to where we had a product that people wanted, and no one else had a similar product. And I had gotten everything that I wanted. Except then was a problem. Once I thought some more, I wanted more, of course. So then we began inventing. But we'd gotten kind of this initial start by this technology we purchased, and we developed more technology so we could do even more and more. So we're now in the business of doing that, and it's going along pretty well. In fact, this weekend we just are in the process of moving to larger facilities and off and running again, so it's kind of fun. So, in conclusion here, I will say that, for the right person, doing a company it's a fantastic job. It really is. And those of you, a few of you raised your hands thinking, you're thinking about starting a company, and I don't care if it's high tech or whatever it is, I encourage you to do it. It can be a lot of fun. It's a lot of work. It's a lot of headaches. But it can really be a fantastic amount. I can't think of a job that's better than that. And I have to say that, the first company is the most fun, but, 4D being, well, I'll say the second company, but I've had other companies that I've been investing in and involved with. First company is most fun, but the other companies are also a lot of fun. And I would love to go back to being 20 years old again, but I don't know how to do that. But, it's a lot of fun to be able to talk about these experiences that I've had with some of the companies. And so I'd like to thank you very much for inviting me and giving me the opportunity to talk about that with that. I thank you.